A patient requires a continuous IV infusion of 0.9% sodium chloride at a rate of 125 milliliters per hour. The drop factor of the administration is 20 drops per milliliter. We want to calculate the flow rate in drops per minute. So let's start with what are we told? So we're given that the patient needs their medicine at a rate of 125 milliliters per hour. So that is our given. We are being asked to find the flow rate in drops per minute. So that is our unknown. We want to know how many drops per minute. And then we are given a conversion here. That conversion is 20 drops per milliliter. So we know 20 drops is equal to 1 milliliter. Now we look at what we have, which is milliliters per hour, and we look at what we want, which is drops per minute. Our conversion right now will turn the milliliters into drops, but we still have to turn the hours into minutes. So we are going to need an additional conversion. In this case, it's that 1 hour is equal to 60 minutes. So we know we need 2 conversion rates to get from our given to our unknown. So now we can set up our conversion table, our dimensional analysis. We start with the fact that there's 125 milliliters given every 1 hour. Then we have our first conversion rate, which is that there's 20 drops in 1 milliliter. So in order to work with that, what we're going to do is we're going to decide where do the drops go, where do the milliliters go? Well, in what I'm given, I have milliliters, so I need to cancel the milliliters out. Since there's milliliters on the top, I'm going to put milliliters on the bottom to cause that to cancel. That means that drops is going to go on the top. Now, if you remember, our conversion said 20 drops for 1 milliliter, and we do see that milliliters cancel. So now we have drops on the top and hours on the bottom. But when we look at our unknown, we want drops and we want minutes. So that means that we still need to convert the hours into minutes. To do that, we're going to use our other conversion rate. We have 1 hour equals 60 minutes. Because our table already has hours in the bottom, we're going to put hours in the top so that it cancels. That means minutes will be in the bottom. Now, hours does cancel. And we have drops left and we have minutes left. So we know we've set ourselves up correctly. Let's go ahead and fill in the numbers as well. We have 1 hour and 60 minutes. So now that we've done that, we can multiply across the top. When I do 125 times 20 times 1, I get 2,500. And then on the bottom, I have 1 times 60, which is 60. So now that I've done the 2 multiplications, we can go ahead and divide those 2 numbers. This comes out to 41.6, and that 6 is repeating, and this is drops per minute. The only thing is, because you can't have part of a drop, we do round this to the nearest whole number, which means that our final answer is 42 drops per minute.